posted to the Clean Water Conversation webpage following this talk. And with that, I will turn it over to David.
Great. Thank you, Sloan. I'm just going to share my screen. Let me know when you can see my slide.
Yes. I can see your
right,
slide.
We can see it.
You said, okay, great. Thanks everybody for taking time out to hear my presentation. My name is Dave Wilcox. I'm the watershed forester with the Vermont Department of Forest, Parks and Recreation. I work with the AMP program. I do a lot of various things in my position, and one is working with DEC in the Clean Water Initiative program to help with technical assistance and planning for private landowners and forest land practices. So I guess I need to do, okay. The goals of today's presentation. I'm going to talk about the AMPs, what they are. We're going to talk about the principles of water quality protection, the actual water quality rules themselves and how they work in Vermont. And then we're going to get into the forest road and trail inventory and specifically the app, the Survey 123 app, and scoring for phosphorus accounting. And then I'm going to show some examples of forest road practice implementation, and hopefully folks will get a sense of what the practices look like, what types of roads and trails we're talking about, and the AMP standards that kind of dictate what practices are necessary. And so, you know, hopefully the AMPs aren't a new. The AMP stands for Acceptable Management Practices. Hopefully they're not a new topic for folks, but they are to provide sound practices for loggers, foresters, and landowners to protect water quality and comply with Vermont's water quality standards. And to kind of get started on the AMPs and what they are. This slide shows some of the practices of you know during and immediately after logging, what loggers and land managers do to protect water quality. On the left side of the slide, you see a brushed in ford that has steel pipes for the water to go through, and then poles and brush on top. It's a winter crossing only, and when that section of trail and that harvest area is done, that brush gets removed, the poles get removed, and that stream is essentially has very, very little impact. And there's a closed out stream crossing in the middle slide, and then the right slide is a picture of a temporary bridge in use on a harvest job in Northfield. And you know, so they're applied on all portions of the harvest, before, during, and immediately after the sale, and those are essentially, you know, kind of a quick look into what the AMPs are. Now I have a brief video I'd like to show, which is talking about the clean water commitment and the forest land practices, and hopefully it will go. Nope. Sloan, any advice? Why won't that go?
If it's helpful, you can either share your screen and open YouTube, or Rachel just sent the link and we can watch it asynchronously right now. So whichever you prefer, we can try those options.
I think I will open it and we can look at it from there.
Okay, great.
I've got sorry about this.
No worries.
I swear it worked when okay, there it is.
I've been
Thumbs up.
logging
Great.
full time since 1987. Before that, I worked with my dad for a while, for probably since I was like 9. Some guys get in it and they're in it for 3 years and they're done. They're on to doing something else, but I mean, I'm in this for a lifetime.
Roughly 73% of the Lake Champlain Basin's land area is forested. Much of this land is far from Lake Champlain and the human impact is relatively minor. But forests in Vermont contribute 15% of the phosphorus delivered to Lake Champlain. Broader use of management practices on private and state forest lands are helping to achieve the goals of the Lake Champlain Phosphorus TMDL.
This area is within the Nebraska Valley Miller Brook watershed. It's a multi-use forest. It has lots of recreation, state parks, ski areas, hiking trails, but it's also a working forest where we harvest timber, we harvest firewood, we harvest all of the range of forest products that we get from our northern forests. We create trails, we create roads, we have stream crossings, and we need to do a good job of protecting the water quality in those areas. When we don't stabilize our trails and remove our crossings, that sediment can travel into headwater streams and eventually make its way to Lake Champlain. And that soil carries the phosphorus, which is the issue, and we want to prevent that.
Water bars are put in to control the erosion, like when it rains, like right now. And if you put them in correctly, there's less erosion.
This is what we call closeout. It's the part of the sale after the harvesting is done. So this flag tells the excavator operator that we need a water bar right here, which will divert the water that's coming down the trail, off the trail, into undisturbed soil, so it will soak in and it won't have enough speed or velocity to have any erosion.
Regulations that the state has on water quality has changed the law. They make sense. Regulations make sense. They rewrote the handbook for the water quality, the AMP handbook.
The AMPs were Vermont's answer to the federal government for how the state was going to maintain water quality on logging jobs.
We set up 5 skidder bridges on this job. 3 were in and maintained at all times, and the other 2 bridges were temporary bridges. We moved from brook crossing to brook crossing, and these are very, very small brooks. But if you don't impact the brooks, it keeps the water clean all the time. Use those portable skidder bridges from the state, and they work excellent. Cordage wise, it's at least 2,500 cord that come across this big bridge right here. 2,500 cords. I'd say 1,500 trips across that bridge with 43,000 pound machine. So bridges do work, and as you can see, there's hardly any impact on the brook. Obviously, you want to try to keep the water as clean as you can. Makes it harder. You just got to work Saturdays and sometimes even a Sunday and just fill in wherever you can and keep your guys going at the same time. I mean, just takes more time, that's all. But it's worth it in the end, you know.
All right, I'm assuming I'm still here. So, so that, what is going on? Sorry, that video was about the forest land sector and our commitment to protecting clean water, protecting water, and how we do that on forest land during active logging. And I talked about a little bit in the video, but does our infrastructure impact water quality? And our work in the woods creates compaction. We build roads and trails, which can redirect water flow, concentrate water flow, can increase soil erosion, and alter hydrology of a site if the AMPs aren't applied to kind of spread that water back out. And we also have stream crossings and opportunities to disrupt the flow and have potential for discharges into those streams as we work in, you know, across and around those streams. So the basic principles of water resource protection that we have in the AMPs can be summed up in, you know, pretty easily with these principles. Basically maintain natural stream flow, have properly sized stream crossings, harden and stabilize approaches, and reduce the number of stream crossings through planning. That's one thing that we really focus on in our logger education and programs with loggers and foresters, is to plan ahead and don't have any more crossings than you need, and try to have good layout, and don't create any issues that are unnecessary because you didn't plan ahead. And so and that goes to all of these things that we're talking about with logging layout and procedures. So the next principle is our forest buffers, and protecting our forest buffers, limiting harvesting within the buffer, and stabilizing any exposed soil within the stream buffer so that it doesn't create a discharge. We have in the AMPs manual, there's tables for various things. One of the tables is for buffer distance. So you look at the slope along the stream, and that will help you to calculate the buffer, and as the land next to the stream gets steeper, that buffer needs to be wider. And these distances are on each side of the stream. So on a 0 to 10% slope, the total buffer width is 100 feet for both sides of the stream. And then to mitigate compaction, we utilize brush and corduroy and sensitive soils. And again, with planning, we try to avoid those sensitive sites like wetlands and seeps and things like that, where machinery is going to sink in and damage the soil or cause rutting. We try to stay out of those sites if we can't protect it with brush or corduroy. And again, planning is key with laying out our skid trails so we can avoid those areas. And then probably the biggest principle and overall general principle of the AMPs is to spread water back out. If we're collecting it in our roads and trails, we want to spread it back out as fast as we can through the use of water bars, broad-based dips, ditch relief culverts if we have a permanent truck road with ditches. And you can see on this slide some pictures, you know, of a water bar. Simple structure. It just keeps the soil from running straight down the fall line of the road, whether it's wheel tracks or depression. A water bar cuts that off and puts the water back into the undisturbed soil. Probably one of the most used tables in the AMP is table 1, which is the spacing of water diversion structures. The percent slope is on the left, and then for whatever category road or trail you're on, whether it's before or after logging, those are the distances between those diversion structures. Yeah, that's a very key part of the AMPs. And in general, properly implemented and maintain AMPs ensure good water quality, and also protect infrastructure, which is a valuable part of forest land. For folks who are managing their forest as a working forest, they need access to do that, and they don't want to have to put a road back together that gets washed out. So this is very important for protecting that infrastructure, as well as keeping the sediment out of the streams. And in terms of responsibility for the AMPs, loggers are responsible when they're doing the work, when they're operating the job, and when the job is completed. The closeout procedures are very important. And that's basically to set the job up for the next period of time where there's nobody in there in the woods harvesting. But those, it could be 15 years before harvesting, and we want that to be stable. So in Vermont, this slide kind of covers the technical rules and so on. You need a discharge to have, you need a permit to have a discharge into state waters. And the AMPs, when implemented properly, relieve a person from the obligation of obtaining a permit for discharges associated with logging operations. So that means if you're logging and you're implementing the AMPs properly, the discharges that occur, the minimal discharges that occur are acceptable to the state and to the federal government based on the way the AMPs are the authority of the AMPs. And in addition to while the loggers are doing the active harvesting, proper closeout of a timber sale is important to stabilize the site and to achieve the presumption of compliance. So it's not just when they're there; it's immediately after they're gone, and that's what we work with our loggers on in education and training practices to what are the good closeout procedures and how far do you put seed and mulch and where does your water bar, how far apart are your water bars and where's the last one go before the stream crossing and so on. Now, the long-term implementation and maintenance of clean water practices, are oftentimes not associated with harvesting. And as I said, logging occurs occasionally every 15 to 20 years, sometimes even more than that. And those AMPs, those water bars and so on need to be maintained so that those trails and roads don't get eroded. And even if you have a good closeout practice, there are things that can limit the effectiveness of those practices. Slope and soils on highly erodible soil and very steep slopes, things don't last as long as they do on better soils and lower slopes. Recreational use of roads and trails can reduce the effectiveness of a water bar or stream crossing. And storm events, obviously, we've all seen impacts from storms over the last few years that can reduce the effectiveness of those AMPs. And in addition, Vermont has had a long history of forest management, and some of the old practices that we used to do left some trails and roads vulnerable to erosion. And so those kind of legacy issues are out there, and we want to try to do what we can to bring those up to the standards of the AMPs. So I'm going to talk about the Clean Water Initiative program and the Forestland practices, where we're assisting folks in implementing these clean water practices in the forestland sector for non-regulatory practices. So this means that active timber harvests on the landscape are not eligible for these practices, and that active harvesting is defined as any time within 3 years after the closeout of a site. So that's what we're considering as the non-regulatory practices. And we utilize the Forest Road and Trail Inventory, which is a new Survey 123 tool to assess road and trail segments. And it was modeled after something that we developed on agency lands. And I actually did a presentation a few years ago on the A&R lands road erosion inventory. We essentially adopted that so that it has a few different features, so we can do it on land where we don't have all of our roads mapped, and with a little bit different road types than we have on our state forests and state parks and wildlife management areas. But it also it does include the same or similar prioritization table for segment scoring, as well as phosphorus accounting, when those segments are improved and brought up to AMP standards. So here's the survey 123. You can find it in ArcGIS, and it's free to use. You just need an ArcGIS username, and we can set folks up with that. We have a forest road and trail inventory, and we have a forest road and trail reassessment tool. So I'm not going to get into the reassessment tool at this point, just because we know that we're going to have to reassess these, because that's how we do our phosphorus accounting. You do the first assessment, figure out the score, then we apply our clean water practices. We go back, we do another assessment, and we hopefully have brought all those segments up to the standards. And there's our phosphorus accounting record, so to speak, or documentation, I guess. We have 3 categories of forest, road and trail that we can do in this survey: permanent truck roads, temporary truck roads, and skid trails. I want to go over the definitions of those things, because it's important to know what kind of road or trail you're on and what those standards are. And so we define truck roads as those roads that go from a public road to a log landing. So they're generally not skidded on. They are accessed by log trucks. And they're designed for vehicular traffic. And some of them are quite good roads. You know, they're crowned and graded, and you can drive on them with a regular passenger car. Some of them are not that smooth and flat, and they have water bars in them, at which point, you know, you're not going to get on them with a car, but they can be very, very good roads. And they're essentially transporting forest products from a log landing to the buyer or processor, and they can be temporary or permanent. The permanent truck roads are open most of the year, say call them 3-season roads. We try to stay off our roads in mud season, because we can hardly get on many of our town roads in mud season. And they generally don't have the base and material that will support driving on in the wettest time of the year. But the 3 seasons, other than mud season, they're almost like a town road. Not as wide, but certainly crowned, ditched, cross drain culverts, permanent stream crossings, base material, often gravel. They're good roads. Our temporary truck roads are built to the same specification as terms of width, and turning and corners and that sort of thing, but they're for short-term use, seasonal use, usually winter season, or very dry summer season. They're generally built out of native material. They don't have gravel. They have surface drainage structures, generally not ditched and with culverts. And in many cases, stream crossings are pulled following the harvesting. So they're not left in permanently like a permanent truck road. And our road, either temporary or permanent, do not include private residential roads and driveways providing access to permanent dwellings. So, or municipal roads subject to the MRGP, like class 4 town roads. So if you have a driveway to your house, and then beyond your house you have a landing, the portion of that road from the town road to your house would not be considered a forest truck road, but the portion beyond that from the end of your driveway to your landing would be considered a forest truck road. And then our third definition, or our third category, is skid trails. And the definition of a skid trail is from the log landing to the stump, or they're designed for logging equipment, skidders, forwarders, feller bunchers, bulldozers, all those kind of, off-road vehicles. So they're not designed for vehicular traffic. Very few skid trails you can drive a passenger car on, or truck on. They're almost always built with native material, and have water bars to divert surface flow. And generally we use temporary stream crossings on skid trails, and the department has in the past few years really prioritized our ability to promote temporary stream crossings by providing rental bridges and bridge cost share programs, so that there are many more bridges out on the landscape, temporary bridges out on the landscape now than there used to be, and contractors are getting very well accustomed to using and relying on those temporary bridges. There's a few more pictures of skid trails. You can see, they're the one on the left is actually during an operation, a summertime, or I guess that would be a fall operation. And the middle one is just after closeout, and the one on the right is also closed out. Which means that the logging is done. Those water bars are at the complete closeout distance apart, and you can see the flags even where the forester or logger had flagged where those water bars need to be, so the operator knows where to put them. And I wanted to have a slide of what isn't a skid trail and where not to use that road erosion inventory, or trail erosion inventory. And so obviously this is a single track mountain bike trail or hiking trail, not designed for forest operations. It's a recreational trail designed solely for that use. So it is not a skid trail. And these could be bike trails, walking paths, ATV trails. And these are not appropriate for the trail inventory program, Survey 123 app, or eligible for QUIP funding at this time. So getting into the Survey 123 app, these are kind of the entry screens for the information. You can see it has a watershed project database number if you have a project, and many folks will know that when they're out doing an inventory. It's very easy to use, very user friendly. You just check the box, and a lot of times it won't let you continue if you missed entering data. So it reduces the amount of errors that we have. And then the screenshot on the right is the actual first page of the survey, and you can see how the questions are very easy to understand, and pretty straightforward and pretty quick to fill out. We can do a segment in I would say 15 minutes, 20 minutes at the most. And some segments are a lot less than that because they don't have much on them, in terms of crossings or culverts or ditches and things. And then some segments can have multiple crossings, so they take a little longer. And I don't know if you notice, there's a checkbox for hydrologically connected. That's probably the well, that is a key to this whole survey, is that we are looking for segments that are hydrologically connected. That's where we're concerned about erosion, because those segments are the ones that will deliver sediment to a stream. If it's not hydrologically connected, it has very little to no chance of delivering sediment to a stream. So we're looking for those hydrologically connected segments, and what we mean by hydrologically connected is a segment that is within 100 feet of a water source, either next to it or adjacent to it, and that includes intermittent and perennial streams, wetlands, and open water, like ponds and lakes and so on, or it bisects one of those water resources, I'm sorry, or if it is a segment that is uphill from and drains to a hydrologically connected segment. So if you had a segment at the bottom of a hill on a road that crosses a stream, and that hill went for, say, 4 or 5 segments, and all of those segments were draining down to that stream crossing, all of those segments would be hydrologically connected, even though they're not within 100 feet of the stream. They drain to a segment that is within 100 feet of the stream. And if those practices failed, if those water bars or ditch relief culverts failed, that sediment would continue directly into the stream and cause a discharge. So once you get over that hill and the water flows a different direction, that is not hydrologically connected to that stream, then you would have to look farther down the road to see if there's another stream crossing that it could be connected to. You know, using mapping and remote sensing, you know, trying to determine how many streams are on the landscape using a map is difficult, because we have good mapping, but we don't have all of our intermittent streams mapped. So it takes some walking around to figure out where the hydrologically connected segments are. So this is a screenshot of I guess this is a piece of private land. This is Catamount Park in Williston, I believe. We were just doing some testing there, basically, of our app, and these are hydrologically connected segments. You can see the pond in the middle of those segments, and I highlighted one of the segments that we did, and you can actually, in this web browser, you can see the scoring of that segment, and you can see the travel lane crown scores fully meets, segment score fully meets, and if it's not live, so I can't scroll up and down through it, but it would tell you all of the different answers to the questions in the app right from this browser. Of course, the data was all collected on a phone in the field, and then this is once the data is uploaded, you have access to it through this means. So when we collect the data for a hydrologically connected segment, we look at 5 different parts of that segment, and each segment is 100 meters, roughly 100 meters long, 328 feet, and we do that so we can break the road or trail up into kind of bite-sized chunks, and 100 meters seemed to be a good distance. It mirrors what they do with the MRGP on municipal town roads, and it's a big enough segment to be efficient, but it's small enough that you can pick up on all the nuances of that segment. But we look at 5 different parts of each segment. The travel lane and crown, which is, think of it as the part of the road that a grader blade would touch. And then the road shoulder and ditch area, which is just outside of that travel lane, to the opposite side of the ditch, the back slope on the ditch. And then the ditch drainage structures like cross drain culverts, And then stream crossings and disconnection practices if we have stream crossings. So sometimes segments don't have a stream crossing, and that section is basically bypassed. And then the last part of the segment is the forest buffer, and that is any area within 50 feet of state water, of a waterway. And the AMPs talk a lot about forest buffers, and if there's any disturbance in the forest buffer, it needs to be seeded and mulched. And then basically that's what we're looking for. Is there are there parts of the forest buffer that is not seeded and mulched? If there is exposed soil. The scoring of the REI, you have three options: fully meets, partially meets, or does not meet. And that's an output of the Survey 123 app, obviously. And then we have a prioritization table, which helps us determine the priority of those segments that are at different slopes. Slope is really a key to the risk, erosion risk. And in addition to slope, stream crossings are also an increased risk. So any segment with failing or undersized stream crossings are considered high priority, because a lot of times stream crossings are on low slope segments. So if we didn't have this little caveat, we would be missing the priority of those stream crossings. So that's where we see most of our issues is with stream crossings, or a lot of the issues are with stream crossings. And then I wanted to go through some. We've been using the road erosion inventory on agency lands for several years now. We've been using it to identify work that's necessary to bring these segments up to the AMP standards. And some of this is, I've got a few slides of some examples of improvement practices on forest truck roads. We haven't gotten to forest trails, skid trails on our agency land. We work with loggers. We have foresters working in the woods on our active timber sales, and we do exemplary work on agency lands as far as the AMPs, and we have a lot of forest roads that were built many years ago, and when the standards aren't such as they are now, and we're working just like any forest landowner to bring those roads up to the AMP standards. So most of these photos are on agency land, and it gives you a good sense of what kind of things work that needs to be done in this road category, so to speak. A lot of recrowning, adding material that can be worked. A lot of our old roads were built out of bank run gravel, and it was difficult to grade them. They didn't hold up as well to traffic. We didn't have as heavy trucks as we do now. And ditch relief culverts are an important thing. We often find where ditches go too far, they don't have enough ditch relief culverts. We're not spreading the water back out as much as we should be. And disconnection culverts, which is right before a stream crossing. You want to run that ditch water across the road, underneath the road, so that it doesn't discharge directly into the stream. And then armoring culvert outlets, and correctly sizing stream crossing structures are also on the list of things that we've been doing. Some examples of road surface and shoulder improvements. That is good material that you can grade, and you can compact, and that will stay. And we've seen in the flood events in the last 2 years, we've seen where our AMP work that we've done, like the examples you see here, held up beautifully in those storms. It almost looked like it didn't rain in a lot of these places where we've done this work. So it works, you know, the stabilization, the better material, the compaction makes a big difference. Ditch relief and disconnection. Here's a good example of down in the middle of the photo. There's a stream crossing. You can't see it because it's in the green vegetation. But this ditch used to go down the side and never had a disconnection practice, and this brings the water across before it gets there. And you can see it on both sides of the stream crossing. There was one installed on the other side as well. So stream crossing structures, you know, this is a washed out in one of the flood events. The water came up and over the road because the culvert wasn't large enough, and it was perched anyways. This is a very steep gradient stream, and here's another view of it from a different angle. There's the before and the after. So we have a properly sized culvert. It doesn't look much bigger, but it is a lot bigger, and we've stepped that water flow down the bank with rocks large enough to prevent erosion and get it down into the stream channel, or continue the stream channel down and be stable and not have almost continuous erosion. So I think that's my last slide of some examples. I wanted to share some future training opportunities that are coming up on the Forestland practices and the Survey 123 app. We're having a virtual webinar type training on Wednesday, April 23rd from 1 to 2:30. This is gonna be kind of an overview of the whole process. We're not going to get into the nuts and bolts of the Survey 123, but we're going to be talking about the eligibility and different project types and tools and resources available. And then we are going to have 2 in-field trainings that's the goal is to get into the nuts and bolts of the REI and do some REI assessments with the group. We want people to come with Survey 123 on their phone, ready to go. And one is going to be down in Poultney at Birdseye Wildlife Management Area, and one is going to be in Montgomery on Jay State Forest. There's a link at the bottom there if you're interested. You can fill out that form and sign up for those. So yeah, I have some time for questions. And I'll leave that slide up there. So if people want to get that URL, I think my next slide is just blank. Yeah. If you want to get that URL, you can do that.
For you, Dave.
Okay, great. Thank you.
Right. And just really quick before we jump into questions, I'm going to launch a short poll, 3 questions, super easy multiple choice, and we'll get as many questions for you, David, as we can.
Okay.
So I'd really appreciate if people fill this out. It should pop up on your screen. Let me know if you're not seeing it. And you can start with Mitchell or Mark Mitchell for our first question.
Yeah, thanks. Thanks, David, for that very informative presentation. So I actually work for the BC Lakes and Ponds program, and always kind of curious about what sort of forestry practices are going on, but it's especially with the legacy logging roads, as you were talking about. And I guess I'm just curious about when you're doing these inventories, especially on private land or let's say like town forest land. I mean, who is responsible for doing these inventories? Is it a volunteer kind of basis? Are you guys going out to kind of like confirming or checking on some of these inventories? And then is there a way to view those inventories so I can kind of see what's going on in like a lake watershed or something like that? What roads are out there and what's been done, what's been inventoried?
That's a great question. That's, you know, we're in the beginning phases of this process. We have, I think, in our map viewer, 5 areas that we've inventoried so far. 3 of them were testing. So we don't have much yet, and I don't know if I could answer those questions, but I think certainly we want this to be something that can be used for watershed planning. You know, the whole private land aspect of this is, you know, some people are more sensitive to you know, what's going on their land, or who's accessing their land, and that, you know, we want people to feel like this is a voluntary effort. This is not regulatory. We want folks to improve their the water quality protections on their property. But it's, you know, and I'm from FPR. I don't know how DEC looks at this sort of thing. So I don't want to go too far out of my lane. You know what I mean? But just to say that, you know, it is going to be an important planning tool, and we want folks to take part in it. But yeah, beyond that, I don't know. I can't really answer those specific questions.
Okay, and just real quick, I mean, is there for at least the A&R lands or state lands, is there a publicly accessible like map viewer currently, or is that
Not
just sort of a
currently,
concern?
no.
Okay.
No.
Okay, thanks.
Yep.
Looks like Dean Pierce asked in the chat if they've already filled out the form for these trainings and not received a confirmation. When do you think that will be sent?
That's another, that's another question for DEC. I think Claire Madden would be the one to ping if you had a question about that. I don't want to throw her under the bus, but that's she's been the one sending out the information. So I would say hang tight. But if you want to make sure you're in the loop, contact Claire.
And I just shared Claire's email in the
Okay.
chat. Yeah, Mark.
Yeah, sorry, just one more follow-up question. So if someone does erosion inventory, let's say on their private land, and they identify some issues, I mean, what are the next steps? Is there funding available for them to put in AMPs, BMPs? Yeah.
Yes, there's a Forestland practice project type through the Clean Water Initiative program, and connecting with a clean water service provider for that. So most often the clean water service provider is going to be the one doing the inventory. The inventory is not really designed for private landowners to do without, well, they're welcome to do it, but most often the clean water service provider is going to be out doing that inventory, and then they would be they're looking for projects where they can do these clean water practices. So that's going to come with the funding, you know, so that's going to be part of that conversation. So outside of that, the Clean Water Funds Initiative or Clean Water Initiative program, you know, RCPP and NRCS, there are a few other programs that help provide money to implement you know, these sorts of things. But specifically, what I'm talking about today is part of the forest land practices, forest land type through the Clean Water Initiative program.
We have a question from Sarah Coleman in the chat. In terms of maintenance of AMPs between logging activities, is there a general guidance for expectation of frequency of operation and maintenance across the range of slope, soil use, and storm events?
That's a good question. Every site has, you know, different variables, whether it's soils being different, weather being, you know, different microclimates, you know, east slope, west slope, north slope, south slope, that sort of thing. Recreational activity. So in general, if you had, you know, average soils and so on with a minimal amount of recreation impacts, you could see your AMPs last 10 years easily if they're built properly, you know, water bars and things like that. But everything changes, you know, when you start messing with those variables, everything it changes a little bit. I would say 10 years is an average. It's not, in some places it may be more, in some places it may be less, but I don't know if that's the type of answer you're looking for, but that's and as you would think, the more variables that you have on a site, you have to adjust your monitoring and your maintenance schedule to account for that.
I'll also add a plug for our operation and maintenance manual, which Dave Wilcox and Silas Rainville worked very closely with our program to develop. It has a couple of maintenance sheets that talk about maintenance for forest practice roads. Go check it out. I put a link to the document in our chat that directs you to the webpage, and then you can access the manual there.
And I think that's a great place to stop. We are a minute over time. But thank you so much, David, for answering these questions and giving us a super informative presentation. Keep an eye out for an email I'll be sending all of you that have attended with information on the recording and slides if you all are interested. But everyone have a great afternoon. Thank you so much.
Great. Thank you.
Thank you. Bye now.
Thanks.